Okay, class, picking up where we left off at, I want to go back and redo that last example. What I did was I moved the figure here at the bottom so it'd be easily seen for examples D, E, and F. Okay, it says find A complement intersect C complement. Now, if we look here, the complement of A is 7, 9, 6, and 8. Now we want to find the complement of C. The complement of C is 2, 4, and also 6, 8. Now, we want the intersection of these two. Now, if you look at the intersection of these two, they only intersect at 6, 8. Those are the only two that they have in common. So that is the final answer here. Now we come here to E. It says find A union C complement. Let me erase these real quick. Now, we have A union C. If you notice, A union C would be all of these numbers here. But this is the complement. The complement is all of the numbers that are not contained in A or C, which is 6, 8. So our final answer here is 6, 8. Now we come to find A complement union C complement. Okay, now this is what we would need to do. The complement of A, we know here is 7, 9, 6, 8. The complement of C, we know here is 2, 4, and also 6, 8. Now we want the complement of all of that. So if we look here, if we union these two, we will add 2, 4, 7, 9, 6, 8. Okay, now we want the complement of that. The complement of all of this would be 1, 3, and 5. This is where they intersect at. So our final answer here would be 1, 3, 5. Now, if we want to go back through that, the complement of A is 2, 4, and also, well, actually, the complement of A would be 7, 9, and 6, 8. The complement of C would be 2, 4, and 6, 8. And if we union those, that would be 2, 4, 6, 8, 7, 9. That would be the union of A complement and C complement. And now we want the complement of their union, which would be 1, 3, and 5, which is our final answer. Now, we scroll to our next example. It says use a diagram to determine each of the following sets. Now, we have find A union B. Now, if we look here, A union B will be all of these elements here. So we will write that out. A union B will be pi e square root of 2 square root of negative 1 e pi I 10 to the 100th power, and also 2. I can't really make this symbol that well, but I'll give it a try. And finally, we will have, actually, that will be it. So this is the answer to A union B, is all of these elements. Now this 1, 2, and 3 is just telling us the regions. That's all. So the elements are these two, and these 3. And also, but we're not doing outside of A union B, but 666 would be region 4. Now we come here to B. It says find A union B complement. Now A union B would be all of these values here like we had up here. But the complement of it would just leave us 666. Now we have A intersect B. Now let's go back here. The intersection of A and B is the square root of 2 and the square root of -1. Now, we want to do A intersect B complement. So it's all the other values that are not the square root of 2 and square root of -1. So it would give us pi e to the pi I 10 to the 100th power 2 to the no and 666. Now we have A complement intersect B. Now to make E and F a little easier, I inserted the same picture here at the bottom so it'll be close to the problem. It says find the complement of A. We know the complement of A is everything that's outside of A, which will be these 4 terms here. This is the complement of A. Intersect B. Now, we know that B is everything in here, but remember it's the complement of A intersect B, so this would be their complement. So, our answer here would be e to the pi I, comma, 10 to the 100 power, comma, 2, and this would be our final answer. Now, we have find A union B complement. Now, we know A is all of these values here. B complement, let me erase this here. The complement of B would be this here. It would be this 666 and also this value here, this pi and E. Okay, so now we want to take A and union it with the B complement, which would be actually these value here, and it's 666. As we would take all the values of A, which is pi E, square root of 2, square root of -1, and we would take the values of the complement of B that does not overlap with A, which will only be 666. And that is the final answer. Now, it says, set and precise use of everyday English. Set operations and Venn diagrams provide precise ways of organizing, classifying, and describing a vast array of sets and subsets we encounter every day, or refers to the union of sets and refers to the intersection of sets. The cardinal number of the union of two finite sets. Formula for the cardinal number of the union of two finite sets. N of A union B is equal to N of A plus N of B minus N A intersect B. This means the number of elements in A or B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A and B. Just basically this. You would put all the elements of A, all the elements of B, and you would not overlap them. All that overlap you would get rid of. For example, if we look here, we did A and B. We would say all the elements of A is pi e square root of 2 square root of -1. All the elements of B is square root of 2 square root of -1, e pi I 10 to the 100, and this 2 to the no set here. Now, the thing about it is when you write out your set, you will only write this overlap in one time. That is basically what they're saying. When it overlaps, you only write it one time. Now, example, some of the results of the campus blood drive survey indicated that 490 students were willing to donate blood. 340 students were willing to help serve a free breakfast to blood donors, and 120 students were willing to do both. how many students were willing to donate blood or serve breakfast? Now, so let's use that formula that we had earlier. We had N of A union B which is equal to N of A plus N of B minus N of A intersect B. Now when we substitute, N of A will be 490 plus N of B will be 340 minus A intersect B, which would be 120. Now this would give us 830 minus 120, which will give us 710. And that would be our final answer. Okay, our next example states 70 students were surveyed about their willingness to help with the blood drive. 20 students said they were willing to serve breakfast and give blood. 25 students said they would serve breakfast but not give blood. 15 students said they would give blood but not serve breakfast. 10 students said they would not help. How many students said they would be willing to serve breakfast or give blood? I made a little Venn diagram here with A being breakfast, B being blood. Now, we had 25 people that would serve breakfast but not give blood, 20 people that would serve breakfast and give blood, and 15 said that they would give blood but not serve breakfast. And then we have 10 out here that neither did the breakfast or the blood. Now, if you look here, they overlap here at the 20. But it says how many students said they would be willing to serve breakfast or give blood. Now that means that this is all encompassed with A and B. So what we will have is this here. We will have A union B, which is equal to, now we know we will have 25 plus 20 plus 15. And that would give us 60. So that would be our final answer. Okay, class, I want to, even though this is the correct answer for this problem, I want to do this problem according to what we just learned, which was this here. A union B Okay, now the screen kept jumping, so I just took the liberty of writing this out. Okay, so we will have N of A union B is equal to N of A plus N of B minus N of A intersect B. Now N of A here is 45 plus N of B is 35 minus N A intersect B, which is 20. 45 plus 35 is 80 minus 20, which gives us 60. Now this was the proper way of doing this. Because we had the Venn diagram drawn, it was easy for us to do it this way. But let's try it this way here because this will help us with other problems. And this is it.